it is time to get triggy in the Unit 3 trigonometry. So we first were doing the SO katoa. So we looked at how do we find missing sides and angles? Well, for sides, we could use Pythagorean theorem if we had two of them. If we had an angle, we could use our SO katoa ratios. So that one stood for sine opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. So if we had a triangle and it's right angled and the angle is here, remember the opposite is when you put your finger here, which side are we pointing at? The one that is opposite. We know the longest, or the one across from here, is the hypotenuse, and then the third one is the adjacent. So if you're looking for sides and angles and you have one of your trig ratios, you want to set up the ratio with the given sides. So if you're dealing with these two sides, that's opposite and adjacent, so you would use tangent. If you're dealing with these two, you would use cosine. But these two, you would use sine. So if you are trying to find a side, you'll be given the angle. But if you want to find an angle, then that is when you're going to use inverse. So for example, sine inverse. And then your ratio would go inside of there. Or cosine inverse, or even tan inverse. And those you can find in your calculator. For radians, we had our conversion as 180 degrees is pi radians, which was half of our circle. And we can find our radian measures on our unit circle for our special angles. So for our unit circle, that is going to give us exact values. That means not in decimal form, but actually with the square root, so square root of 3 over 2. And it comes from the coordinates that you see on the unit circle. So on our unit circle, we had coordinates for each of our special angles, 30, 45, and 60. And for our cosine, that is always the x-coordinate. And then the y-coordinate was our sine. And our tangent was the y over the x. And then we just looked a little bit at the quadrants, so the signs of them. So over here is over and up, so that's positive, positive. So cosine is positive here, but sine is positive as well, and so is tangent. And that was the first quadrant. In quadrant 2, we're going this way this time, so the x is negative and the y is positive. And then in quadrant 3, it's left and down, so negative x and negative y. And then in the fourth quadrant, over and down means positive for the x and negative for the y. So you can see over here cosine's positive, negative over here. And sine is positive in these two, but it's negative down here. And then for an example of some angles, positive angles go counterclockwise. And we'll draw a picture of that. And then negative go clockwise. So if we just kind of sketch a little picture, if the angle was here, let's say this is at pi over 4. If I go the other way, the same distance, this angle would be negative pi over 4. And let's head to the next page. So given a point, how do I find the 6 trigonometric ratios? First step, if you're given a point, is to plot the point. Figure out where it's going to be. So let's say we had the point 2, -5. Over 2, down 5, so it's somewhere down here. My next step is to form the triangle with the x-axis. So the x-axis is here, so I'm going to draw my triangle up here. And that means my angle is there, between the x-axis every time. And then I know that it was over 2, down 5. I've got a triangle, I've got some sides, I just need my last side. So find the missing side, which is here, the hypotenuse, with the Pythagorean theorem. And then from there you can find the ratios. So you can use SOHCAHTOA, and then remember that cosecant, secant, and cotangent are just going to be the flip of those. And the last section we worked on was the graphs. So we had, if our equation looked like this could be an angle, theta, or it can be x. And we also did cosine. So we found that the A stood for the amplitude. And that told us how tall is it. So that was half the distance between the max and the min. Half the distance between the max and the min, that was the amplitude, and it's always a positive number, so it's just whatever's in the front of the equation. So if you look at a graph and you see the amplitude, then you know what it should be in the equation too. And then we also had our formula 2 pi over b, which is also going to always be using the positive. And that was the period. And the period means the length of a cycle. So how long across is it? Maybe it's like pi until it repeats itself. And both of these things can be taken from the equation. They can also be taken from the graph.